Step into Singapore CBD at noon and you'll feel it immediately. The heat doesn't just come from the sun. It's trapped between buildings, reflected from surfaces, and pushed out by air conditioning system. I'm Doris.
Hello, I'm Priyo.
I'm Nathan.
I'm Nicholas.
Hi, I'm Michael.
We're Men in Heat, and today we'll show how a commercial building can be transformed into an active urban cooling system. Our focus is on CDL's commercial real estate segment, specifically Republic Plaza, one of the most dense and heat-intensive areas in Singapore. Urban heat directly affects tenant comfort, energy costs, and asset value. Our solution supports SGD 11 and SGD 13, making cities more livable and resilient while reducing climate impact from cooling. In Singapore, this aligns with the Green Plan 2030. However, current frameworks like BCA Green Mark focus mainly on internal efficiency, not external urban heat. This is the gap we're addressing.
Buildings like Republic Plaza are both contributors and victims of urban heat. We have glass facades reflecting and trapping heat, air conditioning systems rejecting heat outdoors, and dense layouts reducing airflow. This creates stagnant hot air at street level, increasing heat stress and cooling demand. So, the challenge is not just reducing heat gain, but removing trapped heat from the urban environment. So, we propose a 3-layer system: reflect, absorb, and dissipate. First, we want to reduce the amount of heat entering and accumulating on the building. This is where deflecting comes in. It is done through heat-reflective facade treatments and high solar reflectance materials on podium, pedestrian-facing surfaces, reducing solar heat gain and lowering indoor cooling demand. However, this alone is not enough, as reflected heat warms the surroundings. So, that is why we came out with the second layer, absorb. We plan on introducing vertical greenery, a strategic facade zones, functional rooftop ecosystems designed for cooling, not just aesthetics-wise. This delivers 3 benefits. Greenery shades surfaces to lower temperatures. Plant evaporation cools the surrounding air through evapotranspiration. It creates a better experience for tenants, pedestrians, and the urban environment. This is important because SDG 11 isn't about technical heat reduction. It's about making cities truly livable.
Wow, this place is so cooling and livable.
A major problem in the CBD is trapped heat due to poor airflow. Our proposed solution is a solar-powered airflow system, which includes rooftop exhaust fans, facade ventilation channels, and pedestrian-level airflow boosters. This will increase wind speed by 1 to 2 meters per second, remove stagnant hot air, and will prevent heat from being trapped between buildings. So instead of just cooling itself, the building plays an active role in removing heat from its environment.
Now I'll be talking about the business opportunity. Embedding SDG 11 and SDG 13 is not just an environmental move, it also creates real business value. In dense urban areas, external heat directly increases indoor cooling demand. By reducing heat around the building through our deflect, absorb, and dissipate approach, we lower heat entering the building and reduce energy use. This improves indoor comfort, which is a key driver of tenant satisfaction and retention. At the same time, studies show that high-performing green buildings can achieve 5 to 10% higher rental premiums and stronger occupancy rates. For CDL, scaling these solutions across its portfolio not only future-proofs its assets, but positions the company as a leader in urban climate resilience.
So now I'll walk through the impact of our proposal. Environmentally, there'll be a 10 to 20% reduction in cooling energy, lower surface temperatures and ambient temperatures, and reduce heat accumulation. Socially, there'll be improved pedestrian comfort, increased outdoor usage, and more motivation for people to walk around. This is measured through thermal comfort index and foot traffic. From a business perspective, this creates a clear strategic value for CDL. A building that is visibly cooler and more climate responsive attracts higher quality tenants, strengthens brand and ESG positioning, and remains competitive as climate expectations increase. More importantly, this positions CDL ahead of the curve. Instead of reacting to rising temperatures, CDL is actively shaping how its buildings perform in a hotter future. Our proposal is also realistic as it uses technologies that already exist: solar panels, mechanical ventilation system, reflective materials, and green facade systems. What is new is how they are orchestrated into a unified system for Republic Plaza's urban heat context. It's also appropriate because it can be retrofitted. We are not proposing that CDL demolish or completely redesign the building. We are proposing an overlay system that enhances performance using existing structures. In terms of scalability, Republic Plaza works as a pilot site. If proven effective, the same model can be adapted to other CDL buildings in the CBD. We also recognize limitations. Solar-powered systems may have inconsistent output, so hybrid backup is definitely needed. Greenery requires maintenance, plant selection, and irrigation designs, so these designs must be practical. Airflow interventions may vary depending on local conditions, so monitoring sensors must be placed ahead of time to optimize the system performance. These limitations do not weaken the proposal. They show that we have considered implementation seriously.
Urban heat is not just something buildings experience, it's something they create. By transforming Republic Plaza into an active cooling system, CDL can move from reacting to heat to actively managing it at the urban scale.